In this lesson, we will look at Unit 3, Sections 4.4 to 4.5, Fractional Exponents and Radicals. Then we will look at negative exponents. In this lesson, you will learn how to relate rational exponents and radicals, how to express powers with rational exponents as radicals, and vice versa, and negative exponents and their reciprocals. First, let's take a little quick review of the exponent laws that you learned in grade 9. In grade 9, we learned if you have the same base and you multiply, the exponents are added together. If we have the same base and we divide, the exponents are subtracted. Lastly, we have power of a power, where a and b are two integers being raised to the same exponent. Each integer will be raised to the same exponent, in this case the exponent of m. Keep these three rules in mind: product of powers, quotient of powers, and power of a power. We will extend on these a little later. So our first new property is powers with rational exponents with a numerator of 1. When n in our equation is a natural number and x is a rational number, we get this result. The base of x, which is a rational number, is being raised to the exponent of 1 divided by n. The numerator in this case is 1, and the denominator is an undetermined natural number. When we have this, the denominator becomes the index of our radical, and 1 simply goes underneath the radical symbol with the radicand. In our example, if we have 8 being raised to the exponent of 1/3, the 3 is the denominator, 1 is the numerator. 3 becomes our index, while the base 8 becomes the radicand. 1 is the numerator, which is not shown, but is really being raised to 8. 8 to the exponent of 1 still becomes 8 and stays the same. So all we need to say is the cube root of 8, which is 2. However, the numerator will not always be 1. In this case, we look at our second property. When m and n are natural numbers, so our exponents now is another fraction, where m and n are natural numbers, and x is the base, and x is still a rational number. This can be written in two ways. Both m and n in both cases mean the same, but one can have the exponent under the radical, or it could be outside the bracket. Keeping in mind here, n, similar to the first example, the first property there, n still becomes the index of our radical, whether it's a 2 or a 3 or a 4. But now the important thing here, the m, the numerator, is going to go underneath the radical symbol and it'll become a part of the exponent of the base, a. If you find the first part here confusing, you can write it where n is still the index, the base a, the radicand, goes underneath the radical symbol, placed in brackets, and m can be raised as the exponent outside. In our example, we have 8 to the exponent of 2/3. 3, the denominator, still becomes the index. 8 is the base, which is the radicand, and 2 is the exponent outside. When we evaluate this, we're going to do brackets first, similar to BEDMAS, brackets first. The cube root of 8 is 2. We still have to square our base 2, or our answer, and we get an answer of 4. Another new property, what if we have negative exponents? Throughout this chapter and throughout 1201, you will always want your answer to be positive. and to have a positive exponent. So when x is any non-zero number and n is a rational number, x to the exponent of negative n is the reciprocal of x to the exponent of n. That is where we have two new properties being produced. The first, x to the exponent of negative n equals 1 divided by x to the exponent of n. What you have to keep in mind here, as soon as you see a negative exponent, you're going to take the reciprocal of your base. So as you can see in the first example there, 2 to the negative 3, so 2 is your base. We have a negative exponent. You're going to take the reciprocal of your base, which gives you 1/2. The 3, the exponent, stays the same and is going to be placed under the divide symbol. Or we could have 1 divided by x to the negative n, which is the reciprocal of our other property there, and is going to equal x to the n. So you're just taking the first one and putting it in reverse. And the same thing is happening for the second example, 8 to the exponent of negative 2/3. You take the reciprocal of your base, which is 1/8. The exponent becomes positive. It is a cube root, that is your index. Then you're squaring your radical, which gives you an answer of 1/4. In summary here, we have 4 new properties. Keeping in mind, n will always be your index, m is the exponent being raised outside, and we must turn all negative exponents to positive.